Good morning, good afternoon, good evening, wherever you are in the world. Thank you for joining us today. My name is Sarah Alspaugh, and I'll be your webinar producer, coming to you from Cincinnati, Ohio, here in the U.S. I'd like to welcome you to today's webinar, our topic, simulation-driven design. And I'd like to welcome and introduce today's speaker, Patrick Farrell. Patrick brings over 20 years of experience to Siemens PLM. As Senior Marketing Manager, he is responsible for worldwide product marketing of SimCenter CAE simulation solutions. Prior to joining Siemens, Mr. Farrell held product management and application engineering roles at MSC Software and Altair. Mr. Farrell also holds an MBA degree from the University of Southern California and a BS degree in mechanical engineering from the University of Michigan. We're very excited to have you here today, Patrick. I'm going to go ahead and pass you the ball.
All right, thanks, Sarah. Just a quick audio check. Can you hear me okay?
Yes, you sound good.
All right, good. Let me share my screen. All right, so welcome, everybody. Did you say something, Sarah?
I said it looks good.
Oh, okay, good. All right, so yeah, again, thanks everybody. Thank you for joining our webinar today and taking the time to come attend it. As Sarah mentioned, my name is Patrick Farrell, and I work in the simulation and test solutions here at Siemens. So the age of simulation-driven design is here. Simulation is no longer just a performance validation tool. And simulation is becoming an organic part of the development process throughout concept and design. Simulation is leading manufacturers to discover and produce new, unimagined design possibilities aided through new manufacturing processes such as additive manufacturing. Simulation is also helping designers create better, more robust designs earlier in the development process, while also speeding the overall time it takes to release a design, meaning faster time to market. In this presentation today, I will learn more about this new age of simulation-driven design, see how it's made possible, and learn how other companies are taking advantage of this new age today. So manufacturers today face many of the same challenges to stay competitive within their industries. There are bottlenecks in the development process that hinder them from being nimble and making decisions too late. Manufacturers are always looking for ways to cut costs and increase the bottom line. But cutting costs must also be balanced so as not to impact product quality for fear of losing customers. In a competitive environment, product developers are constantly looking for ways to decrease time to market so that you can introduce new innovative products before your competition can. This helps lead to greater reputation and more sales. There's also continuous pressure to create a stream of new products of increasing complexity and functionality. But how do you reconcile this time with the time it takes to innovate with the increased pressure to deliver new products to market sooner? And finally, there's an increasing number of product regulations for companies to comply with around the globe, plus the need to reduce warranty costs, which also impacts your company's reputation to your end customers. So manufacturing costs are like icebergs, meaning there's more than what initially meets the eye. Design decisions made early in the process have a heavy impact on the downstream development costs. When errors are found, it becomes ever more costly to fix those errors the deeper you are into your development cycle. And as this graph from INCOSE and the Department of Defense shows, as a concrete example, 85% of the U.S. Department of Defense project lifecycle costs were determined in the earliest stages of the development process. So it goes to reason that the earlier you know how your product performs, the less risk you have with costly, unforeseen downstream product performance issues. It's better and cheaper to find out issues with your designs as early as you can. Digitalization and simulation have already been game changers in helping companies find issues with their designs earlier than ever before. Simulation can have a huge positive impact on our ability to respond to these changes and has allowed engineers to gain more insight into product performance earlier than with older build and break methods of development. The advancement of simulation has led to increased confidence in simulation results. This means companies are relying more on simulation to reduce product development time, to meet market pressures, and to deliver products earlier. So let's consider the benefits and challenges of simulation as it's been traditionally used to date. Simulation has reduced the need for physical prototypes, and gone are the days of iterative build and break cycles of the past. This has greatly reduced development costs and has also sped up development processes. But traditional simulation still has its challenges. Simulation has been a complex, multi-tool process requiring simulation experts in each of the physics domains. It's also an iterative process between designers and analysts, where designers would come up with a design and then wait for analysts to provide feedback on their design. And since there are usually far more designers than analysts, the CAE team was often overwhelmed, and designers would wait a long time before moving forward with changes to meet performance requirements. What this means is that traditional simulation is a bottleneck. Designers first create the first iteration of a design, then hand it off to the simulation team for feedback. But as I mentioned earlier, the simulation team is overwhelmed, and the traditional CAE process is time-consuming, which means it takes a very long time before the simulation team can provide feedback to the designer. So many times what typically happens is that the designer continues to iterate on a design just based on educated guesses and prior experience. By the time results come back from simulation, the results are already out of date and out of sync with the latest design. This process would continue for a number of iterations, and it often might be that a design gets released before the development organization is fully confident it can meet performance requirements. They hope it passes final testing. Why has this been the case? I already mentioned that there are many more designers than there are analysts, which creates a bottleneck in the simulation process. But even beyond the differential in numbers, historically, there's been a wall between design and simulation. Designers create their designs in CAD, and then through these designs over the wall to the simulation team. The simulation team historically has used a variety of specialized tools for various parts of the modeling process and for differing physics domains and solvers. This is one of the main reasons why the simulation process takes a long time and delays feedback to design teams. But there is good news. The age of simulation-driven design is here today. Innovative manufacturers are taking advantage of advances in technology and development processes to beat their competitors to market with higher quality and longer-lasting products. Simulation is now mainstream, and we're truly in an era of simulation-driven design where simulation can be used to synthesize and define the physical design rather than to simply evaluate and validate completed designs. The fundamental trend for simulation is that it's becoming better, faster, cheaper, and even easier to use. This has enabled simulation to be used earlier and throughout the engineering development process, from concept to detailed design and performance validation. In a survey and report conducted by the Aberdeen Group of various manufacturers, they found that leading best-in-class companies recognize the issue of the simulation bottleneck and are increasingly front-loading simulation into their design processes for use by designers. Aberdeen found that 73% of best-in-class organizations are using simulation as part of their detailed design processes today. This has helped organizations using simulation-driven design methods to reduce their development time by 29%, as well as deliver products that are more likely to work the first time and require less rework later in development stages. So how is simulation-driven design even a possibility? To enable simulation-driven design, we must first remove the wall between design and simulation. Nor can we expect designers to learn how to operate many of the expert-level simulation tools. In this new age, simulation and design must be integrated using a common platform. Design data is not thrown over a wall, but instead seamlessly passes to the simulation tools and experts directly without translation. Similarly, simulation technology can be exposed directly within the design environment. There can be even varying degrees of simulation technology exposed in the design environment. Design engineers might be comfortable with a basic set of simulation capabilities that they can operate on their own to get results. Or, simulation experts can create automated simulation processes that run in a designer's environment to guide them through a standardized workflow for a particular type of part and analysis. In this new age, the underlying simulation technology scales across the entire concept, design, and validation chain. This means your results are consistent throughout development, and it makes maintenance and process management much easier on the enterprise. So simulation-driven design helps you further front-load simulation in your design cycle and shift your development processes further left. With simulation-driven design, it's possible for designers working within their CAD environment. They can actually start the design process by using simulation first that actually helps define what the initial design will be. After getting that initial shape, then the designer can continuously perform a simple qualitative simulation on each design iteration to make sure the design is on the right track. This helps the designer achieve more robust part that can be released more quickly than what your competition can do that is still stuck in the old way of doing things. It also frees up your simulation team by reducing the amount of time spent on routine analyses and lets them focus on more complex types of analyses. As such, at the conceptual stages of development, simulation-driven design can be used to discover new, unimagined design possibilities by using simulation to define a part's shape right from the start. Next, embed simulation into your design process to increase design robustness while speeding development processes at the same time to get to product release faster. And leverage the scalability of an integrated simulation platform to easily transfer designs and prior simulation data to the CAE team to rapidly validate that products meet product performance requirements. Now you might be wondering how your design team is going to be able to perform simulation. You might have heard some of these concerns and objections in your own office. In the past, learning simulation generally requires the learning of at least one new interface or perhaps even several. Even preparing a model for solving can involve multiple steps and applications. For example, one CAD system might be used for authoring the original design data. Another may be used to simplify the model and fix problems. Then the CAE application would be used to apply a mesh, loads, and boundary conditions. All of these different applications make it difficult, especially for an occasional analyst. Others state concerns around accuracy and usefulness of results created by designers. Concerns are often raised stating that producing results is easy, but understanding them is much more difficult. There's much more discussion about how inaccurate results can give a misleading impression about a product's performance, or that results could be misinterpreted, leading to inexpensive or even dangerous mistakes. To help overcome these barriers, we first need to make the simulation process more accessible to designers. Simulation needs to be placed into the CAD environment that a designer is already familiar with. This helps lower the training barrier for pure software operation because a designer doesn't need to learn a completely new software system. Secondly, simulation-driven design actually requires a tighter collaboration between the designer and analysis team. The CAE team's knowledge and experience with simulation is still highly valuable, but with the right tools, the simulation team can capture, automate, and share that knowledge by helping to guide designers with the correct process to perform routine simulation tasks. That's why in this new age, companies are turning to Siemens. Simulation-driven design is achieved through the combination of NX and SimCenter simulation technology. Both NX-CAD and SimCenter 3D and FlowAFD products are based on the NX platform, which means designers and simulation experts can easily share data and technology. Simulation can be exposed to the design team directly in the NX CAD environment for both conceptual design and detailed design work. And simulation experts can have confidence in the results created by the design team since they're using the same fundamental technology, and they can even have control over the types of simulation run by the design team. So now that you know the tools that you need to implement simulation-driven design, let's talk more specifically how you can apply these tools for simulation-driven design. So Siemens offers design-embedded simulation packages that can be used for basic structural, flow, and motion analyses. These are out-of-the-box tools designers can use directly in their CAD environment to simulate designs for structural integrity, basic fluid flow and thermal performance, and mechanism operation for doing things such as packaging studies or interference checking. These simulation models are easy for designers to learn and use, and they can help them make quick design decisions. Oftentimes, if your development team is creating a similar part in each cycle, it's likely that your CAE team performs a standard routine analysis every time for this part. In this case, it's possible to use SimCenter 3D to capture and automate complex yet routine analyses so that they become repeatable processes using best practices defined by your CAE team. These routines can then be packaged and deployed directly in the CAD environment, so now your design team can perform these simulations on their own, which then frees up the CAE team to work on more complex tasks. Ultimately, simulation-driven design within NX CAD gives a designer quick, qualitative feedback about performance of their designs, so they can make rapid geometry changes and iterations before delivering the part for more detailed analysis by your CAE team. Scalability is also critical in allowing the development process to grow from simple analyses into more complex applications later in development. Simple single-part analysis is possible in NX CAD bundles at the entry level. From there, it's easy to progress to the assembly level and onwards to complex multi-physics applications in SimCenter 3D through the NX platform. For example, a simulation model originally created by the design team could be taken and reused later on in more complex assembly analysis by a simulation expert. SimCenter 3D is also solver neutral, so where there is a requirement, any of the major third-party solvers can be used seamlessly with the SimCenter 3D environment. For companies that need to use multiple solvers, the training need is minimized by using a common interface. So customers today are already taking advantage of simulation-driven design to reduce development costs. By putting basic simulation into the hands of designers early in the development process, you can make designers and your CAE team more productive because designers can get feedback on their designs more quickly and your CAE team can focus on more complex analyses. It also means that you can achieve better performing products earlier in development. For example, Renault reduced headlamp costs by 50% within 2 years, partially by using thermal simulation within their design processes to reduce the package size for their headlamp while still maintaining thermal performance of the system. I've also shown how simulation-driven design helps to eliminate the simulation bottleneck. And this then helps you get your products to market faster than your competition can. With simulation-driven design, customers gain a better understanding of how different designs impact product performance earlier, which means you can make better informed product decisions. And since designers are basing these design decisions off simulation, you can spend far less time on final validation and verification downstream. Guangxi Yuchai Machinery, the largest producer of internal combustion engines in China, uses simulation-driven design to help them meet market demands for more personalized products. Greater personalization means more product categories, but with limited dedicated CAE resources, it becomes almost impossible for them to promptly feed CAE analysis results back to design engineers. But by implementing simulation-driven design methods within their designers' NX CAD environments, designers could begin using simulation to get immediate feedback on how their designs will perform. Another example is from Jazo, which develops protective housings for electrical, gas, telecommunications, and boilers. These housings need to permit maximum airflow at the same time, fulfill stringent requirements for fire, rain, snow, dust, and intruder protection. Jazo has an extensive range of products that they then need to customize for each customer's requirements. And so getting a quick turnaround to their customers on performance feasibility is critical. By implementing simulation-driven design into their CAD environment, Jazo's designers now build solid models and analyze airflow immediately. Jazo can then communicate the form, fit, and function of their designs with their customers in less than 1 day, which is a savings of 3 weeks over their previous prototype physical testing-based methods. Innovation is also key to staying competitive, but it's also perhaps the most challenging to achieve. Determining a new part shape isn't intuitive. Many times, designers start new designs simply based on existing designs. They might take a part and try to remove or add material simply by tweaking existing features and dimensions. This means that newer design concepts are never considered, and modifying an existing part might actually create an over-designed part for a particular application. But trying to think of completely new part design takes time. Where do you even begin? Experience helps, but intuition doesn't necessarily create the best part either. If the development schedule is tight, do you have time for a long trial and error process of creating the right part, then simulating to see if it works? Simulation-driven design can help you find the right part shape by using structural performance-based simulation as a starting point to determining new designs. This often leads to lighter designs that can still meet performance requirements. Simulation-driven design also lets you simulate many more design variants earlier in your development cycle, so you can select the best performing designs. Mitsubishi Materials Corporation uses simulation-driven design to study various design variants to optimize the liquid cooling channel opening to improve cooling system performance for advanced cutting tools. Even though Mitsubishi Materials doesn't have specialist CFD analysts, their designers were able to perform the basic CFD analysis easily within their CAD environment and ultimately achieve an 11% increase in flow rate through the cooling system. And finally, front-loading simulation can help you reduce risks in a few ways. First, by automating repeatable simulation processes, you can reduce the risk of error that are associated with doing processes manually. Design Automation Associates has automated simulation processes used to analyze performance of engineered-to-order products. These routine simulations might be performed up to 100 times or more for each design variant that gets created, which means more errors can become more costly and time-consuming across this many simulations. By automating simulation processes and having designers perform those simulations, Design Automation Associates was able to reduce errors and achieve a 100 times faster process. Simulation-driven design also means you can validate performance right the first time. BronzeWorks air-cooled coolers are used as process coolers in the oil and gas as well as chemical industries. BronzeWorks faced a difficult challenge: develop a new cooler and fan and make them as quiet as possible to meet stringent standards set by environmental control boards around the globe. Their design engineers performed analysis of hundreds of variations in geometry to fine-tune the fan and heat exchanger performance and reduce costs without sacrificing quality, ultimately achieving a new fan with 80% efficiency. So the age of simulation-driven design is here today. To reiterate, you can use simulation today to discover new, unimagined design possibilities, embed simulation into your design process to speed feedback on design performance and increase design robustness and achieve faster development processes. And finally, leveraging the scalability of NX and the SimCenter platform to easily transfer designs and prior simulation data to the CAE team to rapidly validate that products meet complex product performance requirements. And before we conclude, I just want to share some upcoming webinars that we have planned that will go into further details and provide product demonstrations on how you can use simulation-driven design, or how you can use and implement simulation-driven design. The next webinar that we have planned for mid-July is on increasing designers' efficiency with intelligently automated simulation. This webinar will spend more time showing how your CAE team can leverage a scalable simulation platform like SimCenter 3D to capture and automate routine simulation processes that can then be deployed to the design community in NXCAD, which they can use then to get immediate feedback on design performance. And in August, we'll have a webinar on how designers can use out-of-the-box design-embedded simulation tools that can be used to improve productivity. These simulation tools can be used for structural, flow and thermal, and motion analysis. And this webinar will show some examples of how design engineers can use these tools to perform their own simulations directly within the NXCAD environment. So keep an eye out in the future for invitations to these exciting webinars, and we look forward to seeing you there. So that really brings me to the end of this presentation. Again, thanks for your interest and attention.
And this officially concludes today's webinar. Thanks again, and have a great day, everyone.